Hello students, welcome back to our channel, YouTube channel Ambedkar sir. This channel is run by Divine School and PU College, Bidar, Karnataka state. In previous videos, we have already discussed some questions of mathematics for class 12th, second order derivative. Mathematics class 12th, second order derivative, exercise 5.7. There are total 17 questions in this exercise. 16 questions have already been discussed. Now let's discuss the last question, question number 17, which is the last question, and then I will discuss some examples also which are there before this exercise in NCERT reader class 12, right? Mathematics. Now the question is question number 17. Question number 17 is, if y is equal to tan inverse x whole square, show that x square plus 1 whole square y2 plus 2x x square plus 1 y1 is equal to 2. This we have to prove. This is given. If y is equal to tan inverse x whole square, y is equal to tan inverse x whole square. This is the given function and we have to get this equation, right? We have to find second order derivative because y2 is there. y2 refers to second order derivative, right? Now, before doing the problem, let's see what is the differentiation of tan inverse x. We have already discussed in previous videos. Derivative of tan inverse x with respect to x, differentiation of tan inverse x with respect to x is 1 by 1 plus x square, right? This is the formula we wrote. Now you can also write it as, differentiation of tan inverse x is 1 by, instead of writing 1 plus x square, you can also write it as x square plus 1. It makes no difference, right? Either write 1 plus x square or write x square plus 1. That makes no difference because 2 plus 3 is 5, 3 plus 2 is also 5. Addition has commutative property. You have studied this in lower classes, right? So it makes no difference. Now, one more thing is, if you observe carefully, this function tan inverse x has a power. So we cannot directly write the differentiation of tan inverse x here because power is there. We have to first clear the power. Before clearing the power, we cannot directly write the differentiation of tan inverse x. So to clear the power, we have to find the derivative of the power also. We know that this is in the form of x raised to n. X, imagine this is all x raised to n. What is the differentiation of x raised to n? Differentiation of x raised to n is n x raised to n minus 1. This n which is in the power must become the coefficient, multiply it to the coefficient, and then from the power we have to decrease 1, make 1 less in the power. This is the differentiation, right? And after doing this, we must find the derivative of this base x only, but that becomes 1. That's why we do not do it. But if it is something else, like for example, differentiation of log x to the power of n, differentiation of log x to the power of n, this is also same as x raised to n. So it will be first n log x to the power n minus 1, n x raised to n minus 1 multiply into, we must find the derivative of 1 by x also. So sorry, we must find the derivative of log x also. Log x will be 1 by x. This is the complete differentiation of this. Now you may be thinking that why did we not do here into, because x will be 1. If I write into, differentiation of x will be 1, it makes no difference. N into x raised to n minus 1 into 1 will be again n into x raised to n minus 1 only. This is how we do, right? Okay, now let's move on to our question. We have to get this as answer, right? Second order derivative. Now differentiate. differentiate with respect to x. Differentiate with respect to x. Find the derivative. So it will be y1 is equal to, I am writing y1, you can also write dy by dx, no problem, or you can write y dash. Now this is in the form of x raised to n. This is all x n. So it becomes n x raised to n minus 1, right? N is 2 here. Into, this is the differentiation of the power, right? Now differentiation of tan inverse x without power. Without the power, now we must differentiate tan inverse x, right? Just now we did here. So what is differentiation of tan inverse x? 1 by x square plus 1. Differentiation of power into the differentiation of base then. This is completed. Now, this is first order derivative, right? Now, take this x square plus 1 to LHS. Take this x square plus 1 to LHS. It will multiply with y1. So, it becomes x square plus 1 y1 is equal to, what is left here? 2 tan inverse x is left. So, what about this 2 minus 1? 2 minus 1 is 1. When power is 1, no need to write. Right? We got this. Now this is first order derivative. Differentiate this again because we have to get second order derivative y2. Right? So differentiate again. Again differentiate with respect to x. Again differentiate with respect to x. I am writing DIFF as a short form of differentiation. Differentiate. Right? So again differentiate with respect to x. So here in LHS it is uv. There are two functions, u into v, u into v. Here 2 is constant, we can directly differentiate tan inverse x. Right, but here we have to apply uv. uv rule, what is uv rule? Product rule. First function as it is into differentiation of second. What is differentiation of y1? y2 plus second function as it is into differentiation of first. What will be the differentiation of this? X square will be 2 into x raised to n minus 1, right? 2 minus 1, right? It is x raised to n. It will be 2x to the power 2 minus 1. 2 minus 1 will be 1. Plus 1 is 0. So first function as it is, differentiation of second, plus second function as it is, differentiation of first is over. Is equal to, we have to differentiate RHS also, we cannot leave. So 2 constant as it is because it is in product with the function, and then tan inverse x differentiation is 1 by x square plus 1. You can write 1 plus x square or x square plus 1, makes no difference. Right, so this becomes x square plus 1 y2 plus this 2x plus 0 is 2x. 2x plus 0 is 2x. 2x into y1 is 2x y1 is equal to 2 divided by x square plus 1. Take this x square plus 1 to LHS. Take this x square plus 1 to LHS. This x square plus 1 will multiply with this all, right? So it becomes x square plus 1, this x square plus 1 I have taken here, into this one, right? X square plus 1 y2 plus 2x y1 is equal to, what is left here? 2 only, because this we have transferred here. So 2 is left only. Now, this will multiply to both terms, right? This will multiply to both terms. So this will become x square plus 1 into x square plus 1, x square plus 1 whole square y2 plus this multiply to this is over. Now this will multiply to this also, right? So it will become plus 2x, I write this, into x square plus 1, this multiplied here into y1, right? This 2x, then this is multiplied here, then y1 is equal to, what is left here? 2. So we got the required answer. This is the required answer. X square plus 1 whole square y2 plus 2x into x square plus 1 y1 is equal to 2. This is question number 17, solution to question number 17. Let's solve some examples that are before this exercise in your reader, NCERT class 12 mathematics reader, right? Next example, example number 38 in the book. Example number 38 is there before exercise 5.7. Question is, find d square y by dx square if y is equal to x cube plus tan x. A function is given, y is equal to x cube plus tan x. We have to find second order derivative, right? So write down the given equation, y is equal to x cube plus tan x, right? Now differentiate with respect to x twice, that will give you the answer, right? Now differentiate with respect to x, that is first order derivative. Differentiate with respect to x, that will be the first order derivative. So y will be dy by dx, differentiation of y with respect to x, and x cube differentiation will be, this is in the form of x raised to n. X raised to n is n x raised to n minus 1. So 3 will multiply here, 3x, 3 minus 1 will be 2, 3x square, plus differentiation of tan x. Differentiation of tan x is sec square x. You can directly differentiate this. Differentiation of tan x is sec square x. First order derivative is over. This is first order derivative, but we have to differentiate again because we have to get d square y by dx square, second order derivative, right? So again differentiate with respect to x. Again differentiate with respect to x, right? So that will become d square y by dx square. dy by dx becomes d square y by dx square. First order derivative becomes second order derivative. This is 3x square, 3 constant as it is. Differentiation of x square will be 2 will multiply here, 2 x raised to 2 minus 1 will be 1, no need to write, right? Plus this is again in the form of x raised to n, but base is not just x, base is sec x, right? So first we will do it in as x raised to n, then in product, in multiplication we will also differentiate sec x, right? So it becomes 2 will multiply here, 2 sec to the power 2 minus 1, that will be 1 x, right? This is the differentiation of just the power, right? Now without power, we have to differentiate the base also, that is sec x, right? Differentiation of sec x is sec x into tan x. This is the differentiation of sec x. Derivative of sec x is sec x into tan x. See the formula list in the first video of second order derivative. Before starting I wrote the list, right? Okay. Now simplify, that's it. D square y by dx square, second order derivative will be, this becomes 6x, right? 6x plus this will be 2 constant, sec x into sec x becomes sec square x into tan x as it is. No more simplification is possible. So this is the answer. Let's see the next problem. Next example, example number 39. What it says, if y is equal to a sin x plus b cos x, then prove that d square y by dx square plus y is equal to 0. This we have to prove. We have to get this after differentiating twice, that is second order derivative. Let's take the given equation. Given equation is y is equal to a sin x plus b cos x. A sin x plus b cos x, right? Differentiate first order derivative with respect to x. Keep in mind that capital A and capital B, A and B are constants here. A and B are constants. So differentiate with respect to x. Differentiate with respect to x. So it becomes dy by dx is equal to, dy by dx is equal to a constant as it is. We know that when constant is multiplied to function, we must keep it as it is. If constant is alone, then differentiate and that will be 0, right? differentiation of constant is 0. But here it is in multiplication with a function, so we keep it as it is. Okay. Constant a as it is. Differentiation of sin x is cos x plus b constant as it is. Differentiation of cos x is minus sin x. Because b and cos are in multiplication, that's why I'm writing bracket. Right? That's important. Okay. Then therefore dy by dx will become a cos x plus into minus is minus, plus into minus is minus, b sin x. We got first order derivative. This is the first order derivative. Now differentiate again because we have to get second order derivative. So that will be again differentiate with respect to x. Again differentiate. So dy by dx will become d square y by dx square, second order derivative, will be equal to a constant as it is. Differentiation of cos x is minus sin x. Right? Cos x differentiation is minus sin x. Cos x minus b constant as it is, this minus, and then b constant as it is. Differentiation of sin x is cos x. So it becomes d square y by dx square is equal to, take minus common, so it becomes a sin x. Since we are taking minus common, when we take minus common, what happens? Positive becomes negative, negative becomes positive. This is negative, because of this minus and it became positive. Then this is also negative, it becomes positive because we are taking minus common, right? Plus b cos x. Right? Now, d square y by dx square is equal to minus, if you observe carefully, a sin x plus b cos x is the given equation, that is equal to y. A sin x plus b cos x, a sin x plus b cos x is equal to y. So can I replace this by y from this equation, make it equation number 1, make it equation number 1. So this becomes y. Why? Because from equation 1, right? This is y, it is given in the question, right? Now take this minus y here, it becomes d square y by dx square. Take minus y here, it will become plus y is equal to, what is left after the sign, equal sign, that is 0. Nothing is left because we have taken this here. This is the required equation, d square y by dx square plus y is equal to 0. Hope you understood the question. Let's try another problem. This is example number 41. Example 41. We did example 39. Then 40 I left it because I want you to do it, because a similar question we did in exercise. Because example number 40 is quite similar to one question in exercise 5.7 in previous videos. Right? Try it yourself. It's very easy, right? Now, example number 41 is, if y is equal to sin inverse x, then show that 1 minus x square into d square y by dx square minus x dy by dx is equal to 0. This we have to prove, right? So take the given equation. The given equation is y is equal to sin inverse x. Y is equal to sin inverse x. So differentiate with respect to x. Differentiate with respect to x. It becomes dy by dx is equal to 1 by root 1 minus x square. Differentiation of sin inverse x is 1 by root 1 minus x square. Now, before going to the next order derivative, that is second order derivative, do one thing. Take this 1 minus x square here. Transfer 1 minus x square to LHS. So it becomes root 1 minus x square. It will go to numerator. That will be dy by dx is equal to, what is left here? 1. We transferred this here, right? Now differentiate again. Now differentiate once more. Again differentiate with respect to x. Again differentiate with respect to x. So that here we have to do UV rule, right? UV. You have to differentiate using product rule, UV rule. First, then U into dV by dx plus V into du by dx. U root 1 minus x square, U as it is, into dV by dx, differentiation of V. So dV by dx differentiation is d square y by dx square. First function as it is, differentiation of second, plus second function as it is, differentiation of first. This is in the form of root x, right? What is the differentiation of root x? Differentiation of root x is 1 by 2 root x, right? Then we must differentiate in product. We must differentiate this inside the root, whatever is there, x, but it becomes 1. That's why we do not do it. But here, along with root, we do not have just 1 minus x. We do not have just x, but we have 1 minus x square, right? So we cannot just leave it. So differentiation of this will be 1 by 2 root 1 minus x square. Root x differentiation is 1 by 2 root x into, we must differentiate this also without root. Don't see the root. 1 minus x square we must differentiate. 1 will be 0 minus x square differentiation is 2x. Right? So first function as it is, differentiation of second, plus second function as it is, differentiation of first, root x 1 by 2 root x. Then without root, differentiation of 1 minus x square. 1 is 0 minus x square differentiation is 2x. Is that right? Is equal to, we must differentiate RHS also. What is in RHS? 1. It's constant, right? Differentiation of constant is 0. 1 becomes 0. Now, this becomes root 1 minus x square into d square y by dx square, then plus dy by dx into 1 by 2 root 1 minus x square into minus 2x, right, is equal to 0. 0 minus 2x is minus 2x, right? Now, this 2 and this 2 gets cancelled. Okay, and then, now do one thing, we got this one, we have got this. I'm writing here now. After this step, it's here. Root 1 minus x square into d square y by dx square as it is, right? Plus dy by dx into, wait, do one thing. This plus into minus becomes minus, right? Take it minus. We have plus here and a minus sign is there, right? They are all in multiplication. So plus into minus is minus. dy by dx 1 into 1 by root 1 minus x square into 2. Sorry, 2 word cancel, into x is equal to 0. Here, take LCM. Root 1 minus x square will be LCM. Root 1 minus x square will be. Don't take this dx square or dx as LCM, otherwise it will be wrong, right? This is all second order derivative. It's actually y2. It's actually y1. Nothing is there in the denominator, right? Okay. Root 1 minus x square we do not have here in the denominator, so it will directly multiply with this. Root 1 minus x square into root 1 minus x square, that will become root 1 minus x square whole square d square y by dx square minus, here also root 1 minus x square will get cancelled, dy by dx into 1 is dy by dx only into this x is equal to 0. We took root 1 minus x square LCM here. Or then this square and root will get cancelled. So what is left? 1 minus x square into d square y by dx square minus this x dy by dx as it is equal to, take this here, right? Take this here. So it will multiply 0 into root 1 minus x square. It will multiply with 0. So 1 minus x square into d square y by dx square minus x dy by dx is equal to, we know 0 into anything is 0. We got the required answer, right? This is how we do it. With this we have completed second order derivative exercise as well as examples. One example only I didn't do, I left it for you. I want you to complete it. And in the next video we will see again differentiation only, but from differentiation one more topic is there. Actually I should have done that before this, but I moved on to second order derivative. Derivatives of functions in parametric forms. We'll do parametric forms. Functions in parametric forms will be started in the next video. Thank you for watching.